So, you've gotten pretty good with SQL, right? You can create table with your eyes closed, and you know your way around a select statement. That's awesome, but that's really just the starting line. The real power, the stuff that separates the pros from the beginners, is when you stop just writing queries and start architecting database systems. So, let's go ahead and open up the Professionals Toolkit.
Does any of this sound familiar? That query that used to be instant is now, well, it's taking its sweet time. Or maybe you're writing the same crazy, complicated join over and over again. And then there's that little voice in the back of your head wondering, wait, who has access to all this data? And is it even reliable?
If you're sitting there nodding your head, then you are in exactly the right place. We are about to unpack the power tools that solve these exact problems. We're going to focus on three big things: speed, simplicity, and security. All right, first up, let's talk about the #1 problem everyone runs into with databases: slowness. You know, when your database gets bigger, with thousands or even millions of rows, finding what you need can start to feel like it's taking forever.
And the solution to this is something called an index. Now, the absolute best way to think about an index is to picture the index in the back of a textbook, right? Instead of flipping through every single page to find a topic, you just look it up in that organized list at the back, and boom, it tells you exactly which page to go to. A database index is the exact same idea. It's not the data itself, it's a map that points to the data.
So without an index, when you ask your database for something specific, it's like asking it to find a single word in that huge textbook, but with no index to help. The database has no choice but to start at page 1 and scan every single line of every single row until it finally finds what it's looking for. We call this a full table scan, and trust me, it is painfully slow. Luckily, the fix is actually super simple. With just one command, create index, you're basically telling the database, hey, listen up, I'm going to be searching on this column a lot, so do me a favor and build a shortcut for me. You're giving it the instructions it needs to create that internal map for lightning-fast lookups. And the result? Oh, it's dramatic. The very next time you run that query, the database doesn't scan anything. It just looks at its new index, finds the exact location of the data, and jumps straight to it. And we're not talking a small improvement here. This can take a query that used to take minutes and make it run in milliseconds. It's a total game changer.
Now, indexes aren't a totally free lunch. That map has to be stored somewhere, right? So it takes up some disk space. And every single time you add, delete, or change your record, the database has to update the index too, which adds a tiny bit of work. So the key here is to be smart about it. You only want to create indexes on the columns you search on all the time, not on every single column in your table.
Okay, so we've solved for speed. Awesome. Now let's tackle the next big headache: complexity. Because as our databases get more interesting, our queries, well, they can become absolute monsters. You know the query I'm talking about. The one that joins like 5 different tables, has a ton of where clauses, and is 50 lines long. It's a total pain to write, it's even harder for someone else on your team to read, and if you make one little typo, you get completely wrong results.
The elegant solution to this mess is something called a view. And the perfect analogy for a view is a shortcut on your computer's desktop. That shortcut icon isn't the actual program, right? It's just a simple thing you click on to run all the complicated stuff behind the scenes. A view is exactly that. It's a saved select statement that you give a simple, easy-to-remember name.
And here's how it works. You take that big, ugly, complicated query, you write it one time, and you just wrap it inside a create view statement. So here, we're making an address book view that neatly pulls together info from the customer table. All that messy logic is now tucked away under one simple name. And here is the payoff. Now, instead of your whole team having to write or even remember that monster query, they can just type select star from address book. And they get the exact same results, but with a query that's clean, simple, and basically impossible to mess up. This is a massive win for both getting things done and keeping your data consistent.
Okay, so we've got speed and we've got simplicity. But what about control? How do we protect our data from people who shouldn't see it? And how do we make sure the data itself is reliable? This brings us to the twin guardians of our database: security and integrity.
First up, security. This is all about controlling who can do what. I mean, you probably don't want the new intern to accidentally delete the entire customer table, right? The main tool we use to manage permissions is the GRANT statement. So you have the database administrator, or DBA, who acts as the gatekeeper.
Using the GRANT command, they can give a specific user very specific permissions, like you can select from this table, but you can't update it. And just as easily with the REVOKE command, they can take those permissions right back. It gives you really precise, granular control over your data. Now for the other guardian, integrity. This isn't about who can access the data, it's about making sure the data itself actually makes sense. To do that, a database has to enforce two critical non-negotiable rules.
Rule number 1 is entity integrity. This sounds fancy, but it's super simple and absolutely vital. It just means every single row in a table must have a unique identifier, its primary key, and that key can't be empty. I mean, think about it. You can't have two products with the exact same product ID, and you can't have a product with no ID at all. Every single thing needs a unique identity. Rule number 2 is referential integrity. This one is all about the relationships between your tables. It basically says that if you have a foreign key in one table, like a customer ID in your orders table, that ID has to point to a real customer that actually exists in the customers table. This is what prevents you from having orphaned records, like an order that doesn't belong to any customer. It makes sure all the links in your data stay valid.
So we've got indexes for speed, views for simplicity, and these really important rules for security and integrity. But here's the thing. These tools don't just exist in a vacuum. A professional doesn't just wake up one day and start creating stuff randomly. They follow a plan.
And that plan is called a database lifecycle, or DBLC. You know, you wouldn't build a house without a blueprint and a construction plan, right? Well, you don't build a professional database without a structured process either. This flowchart shows you the main steps, from the very first idea all the way to long-term maintenance.
And honestly, these early design stages are the most important. You start with conceptual design. That's the big picture idea, the kind of thing you'd sketch on a whiteboard to figure out what you're building. From there, you move to logical design, where you turn that rough sketch into a formal blueprint, like an entity relationship diagram. This is where you map out every table, every column, and every relationship before you ever write a single line of code. So let's bring it all home. Mastering these concepts is what really elevates you from being just a coder to being a true architect. You use indexes for speed. You create views for simplicity. You implement security for control. You enforce integrity for consistency. And you do it all as part of the DBLC, which is the plan.
Once you master these tools and this process, you're not just someone who writes SQL anymore. You're a database designer. You're someone who can build systems that are fast, simple, secure, and reliable. So, you've got the blueprint, and you've got the tools. The only question left is, what are you going to build?